Newton's laws. We're going to start off looking at three of them, and to begin with, we're going to look at the first one, which is probably the stupidest law ever. You all know it. Objects in motion stay in motion. Objects at rest stay at rest. It's like, duh. See, object at rest. Object that is at rest stays at rest, and if objects that are moving stay moving, this law sucks. What is wrong? Why can't I get a law that works? Look, the genius of Newton and the genius of Newton's law is that Aristotle was first one who started saying, well, like, look, things actually, their natural state is to stay at rest. Like everything you know is sitting there, right? And he said the only time things move is when we move them. He actually invented the idea of a prime mover because there were these pesky things called planets that just kept orbiting and orbiting. And they were trying to figure out, like, what's going on there? If everything naturally comes to rest, why is it that the planets keep going? And so it wasn't until Newton who came along and said, like, no, that's actually, like, we have it backwards. That there's this thing called inertia, which we'll talk about later when we talk about the second law, but this thing called inertia, and when things are at rest, they tend to stay that way. They tend to stay stationary. But when things are moving, they tend to keep moving. But here's the thing. When I said the first law in the first part of this video, I purposefully said it wrong. Okay? The whole law is completely important. You have to pay attention. So the whole law says that objects at rest will remain at rest, and objects in motion will remain in motion at a constant speed in a straight line unless acted upon by a net outside force. Okay, so I've got my object. It's at rest, but this object seems to start moving. Well, what's going on? I don't know if you can see it, but there's actually an incline here. So you can see my finger going up and down on your screen there. So gravity is a net force. So first we have to describe what is a net force. So if I push on this ball in opposite directions, like the two forces cancel out, and it actually applies zero force to the ball. Because I've got a force going to the left and a force going to the right. And if I give that a reference frame, let's call one of them positive, one of them negative. If they're the same, when I add them together, I'll get zero. So I need a net force. I need a force that does not cancel out. So in this case, here's my object at rest. I let it go, and it takes off because gravity is a net force acting on there. There's nothing that balances the gravity, so the thing takes off in the downward direction. The next thing is that I need a net outside force. Okay, so I'm sitting here on a chair, like, how come I can't? I'm pushing how come I'm not sliding across the floor? I'm not moving at all. Why not? Because all the forces I'm trying to put on something are from within me. I need those forces to come from outside. So earlier example, you saw the ball fall. The ball was falling because the force of gravity came from outside the ball. So I need a net force, which means, like, it can't be balanced by anything else. I need an outside force. The force has to come from outside. And then I can actually begin to accelerate. I can change my motion. So let's look at the other one. I said, well, look, here's my object. I put it in motion. How come it doesn't stay in motion? Well, there's friction on this thing. It's sliding on an incline. There's friction. The friction is a net force. There's nothing balancing that friction at this point. The friction acts from outside the box. So Newton's law holds this object would stay in motion, except for the fact that there is an outside force that is unbalanced, that keeps it from continuing to move.